Okay, so to kind of start us off, I'm just going to give a background of the DGGS Airborne Geophysics Program, sort of how the current data collection that's publicly available came to be. It's only fair to give a background of the organization we work for, which is about that as the Division of Geologic and Geophysical Surveys. We're based out of Fairbanks, most of us. Okay, so this is in your handout, but basically we have all these state statutes listed. You can go online and read them all. But the real goal of our survey is we have basically an economic development arm where we're getting data, we're putting it out for the public to drive development and resource development in the state, which will pay back to the state in terms of job creation, taxes, and all that other stuff. Then there's probably another arm of that, which would be hazards, and there's whole groups dedicated to that, which ensures like proper infrastructure planning, safety, like coastal management, tsunami and inundation. Then you can also think of another group which didn't, we're part of the Alaska Volcano Observatory.
Okay. Everybody here?
Can you hear me okay? I need the mic. Okay, good. Actually, I asked you another question. How many geologists in the room? And any geophysicists? Okay. So some of this will be reviewed for two of you, and then some of my talks, and then the geologists will put together. Okay, so back to our group. There's about 46 of us, most of us in Fairbanks. There's another place here. And we have a director, an operations manager, director who oversees our general direction we go, finds funding, stuff like that. Then we're divided into the groups listed. One of them I forgot, which is volcanology, which is we're part of the Alaska Volcano Observatory. So the group most of the people in this room are most familiar with and most interested in is the minerals group. And that's really where most of the geophysics data that I'm going to talk about comes from, and that's the group that goes out and does detailed mapping, publishes all the geochem that you like, and kind of sets the stage for exploration projects. There's the engineering geology group that does the hazards, infrastructure, permafrost, hydrology, studies like that, gravel mapping. Then we have the energy group, that's all hydrocarbon support, so oil and gas, a lot of work on Cook Inlet and the North Shore. Geologic Materials Center, that's here in Anchorage. That's a really awesome building, repository for drill cores, rock samples, and other physical items that are valuable to the state and to geologists. It's a really great place that you can go visit it. And the Geologic Information Center, that's a group that's responsible for sort of keeping the lights on and getting all our stuff published and online. And then there's an admin group like everywhere else that really keeps us running. This is an interesting fact. Right now, our salaries are about 59% state funds, and the rest are other sources. The project balance is probably even less state funding, but in terms of salaries, it's right there. So let's talk about the DGGS Geophysics Program, sort of from the 1990s onward, because that's really the data that we're going to talk and focus about in this workshop. So amazingly, there's really just one person for the majority of it, and that person had a lot of other duties a lot of times, like being a section chief or maybe some other project duties. And the primary focus was mineral support airborne data, and of course that had internal and external uses. I'll talk about that more later. And really most of the funding came from the state, a program called the Alaska Geological and Geophysical Minerals Inventory Program. And the focus here was collect the data and publish it. And as usual, both DGGS offices are like a public resource. We take public questions and we answer them. I field all sorts of questions. It's pretty interesting what you get sometimes. And then it started to transition about 2015. We started the geophysics group, which is 2 people, started supporting the engineering group, so applying some of our airborne data to other things besides mineral projects. We have a lot more mixed funding now, a lot more federal funding. Like I said, one permanent staff member, one non-permanent staff member. More data types. One of the projects that we're into now is involving some interpretation, more so than just geologic mapping. And we continue to be a public resource. And one of sort of my missions that I'm interested in is improving data access. I'm always trying to get more data online, more stuff available to you that we have. And just as a side note, I'm not a seismic geophysicist. My focus is on like the minerals and the engineering, and mostly like airborne, mag, gravity. But we do now, through Division of Oil, Gas, and Geologic Materials Center, we actually are hosting state-funded seismic data that is available for sale now. So it's not my part, but it's just something we do. And this is really the map we're here about. This is the public resource, the geophysics data that's available now as of this year. And so basically what we have for Alaska, and remember how big Alaska is, so this is a lot of area. We have about 60% of the state covered in airborne EM data, 1% radiometric, which that's higher, but it's hard to get, and then 16% of mag, and this is, I'm calling modern, like sort of post-GPS position, 1990s or newer data. And you can see the blue and the light orange there are all sort of the helicopter, airborne, electromagnetic and magnetic data with occasional radiometrics. And most of those are state funded, indicated by the blue, and there's some federally funded ones there. It's a mix of state funds. Then there's some fixed wing mag, DGGS managed, showing up in the pink and the dark orange. And then some USGS data that's readily available to sparser space. Okay, so this just steps back to the program that was responsible for most of the EM and mag data. It's the Airborne Geophysical and Geological Minerals Inventory Program. And this was started in the early 1990s, and it was really to promote mineral exploration and get a better understanding of the mineral wealth of Alaska. So, and really we're trying to have an economic impact. That was the whole goal of this. Offset, this is the exact wordings of the bill, to offset declining oil revenue, which is where we're at right now. No new mines are online right now, unfortunately, but that's the goal of this, was to generate that sort of interest in financial input. And just to mention, so there was a lot of areas, I'll show you a map in a second. At the start of it, there was a bunch of candidate areas chosen, like these are the highest priority areas, the greatest potential for mineral wealth. And they were chosen not just by DGS internally, but with external input, and people like you sitting in the audience. It'd be interesting to do that exercise again and see what we come up with. And then the products from this program generally included publishing the geophysics data, upgraded geologic maps, geochemistry, and other data that we put out at DGGS. It's a great resource. And this is, I don't have the original map, I couldn't find it in my archives, but basically as of 2000, this is sort of the map of Alaska and where the program was. So you have the red circles there, the dots, and these were all the sort of priority areas that were chosen at the time. And then in the blue, you can see the dark blue there, you can see the surveys that had been done as of 2000 anyway, actually the map is a lot more filled in now. And then the state lands, I won't actually mention that, the focus was on state lands or state organization, kind of the hash green areas there. So just moving on, and then I'll mention, as we move forward in time, that program got another boost. It's called the Strategic and Critical Minerals Assessment. The Capital Improvement Project, kind of a mouthful, but basically this was started in 2012. And it was a boost of state funding to determine Alaska's potential for rare earth and other essential critical minerals that are politically sensitive minerals. And this was a great source of funding. It started, there was sort of like a research component of it, just sort of compiling all the existing data on these type of mineral occurrences and where they might be. I also considered funding for reanalysis of a lot of rock samples we had in our physical inventory with better geochemistry, and then there's geological mapping, and of course more airborne geophysics. So there were some surveys that resulted from this. And those two programs ended basically with the curve of oil prices in 2015, the drop of revenue. So. And this is just a lot of people in this room kind of fall in the program over here. This is the classic map of sort of promoted every year where you have, in this case, the triangles of more priority areas we hope to get to, and then showing the surveys done to date. Then I just want to step forward to two of the more recent surveys that DGGS has managed. And these, this is the lower circle there is near Toke, is the Tanacross survey, and the upper one in northeastern Alaska is called the Porcupine survey. I'll just briefly mention that these were funded by the USGS Minerals Resource Program. So our last two major surveys actually came federally funded. And they were both quite large surveys. So just quickly, at the end, I hope we'll maybe do like go over this more specifically, or how to get at our data, how to download it or order it, or whatever it might be. But I'll just give you an overview of how it's available first. I'll talk about that. The first stop is our website, and it's not just geophysical data that's there. DGS has a lot of really great data for your projects. The elevation data for the state is improving daily with the updated IFSTAR data and with any local LiDAR collections. That data is really useful if you can get a hold of it for your projects. And of course, there's geologic maps, geochemistry, and much, much more on our website. And then Sue will correct me if I misspeak on any of the USGS sites, but basically the US Geological Survey has its own website. And two sort of sub areas you want to think about is research called Mr. Data, that's focused on minerals, resource data, and science-based. You'll find good resources there. And don't forget about our neighboring agencies, because geology crosses borders. So this is our website. It's just the Geophysics Program page website. I just put up, it's pretty simple, and I got some basic information up there. If you click on this map here, this brings you to an interactive tool. This is soon to be updated, but it's a pretty nice tool. You can cruise around and you can click on, if you know where you want to go in Alaska, you can click on the surveys, and the data is available for download. It'll give you links to that, or if not, it tells you the survey name, what type of data, and how to order it if it's offline. So currently, about a third of our data, part of it's online. So we have a lot of work to do to getting it all available and downloaded. And then, if you're really familiar with the area, you know the name, there's also another little sub-page on the Geophysical page. It's just a list of the surveys. So a lot of us know, like, hey, I need this survey, and then you just go straight there and you can download it and or order it from us.
Question?
Yeah. Sorry.
What is the format of the data when you download it?
You get lots of different formats. I'm actually trying to cut back, but at a minimum, there'll be an ASCII format, so you can import it right into whatever program. But I usually just try to save people time. I don't use super popular, so those formats come out, and then I try to be ARC friendly too, geotips and other stuff like that. So there's shape files. It's a long list. Probably too much, but it's good, because if you want it, then you don't have to make it. So try to balance those two things. And as an aside, actually, going forward, we're going to start publishing inversion results and figuring out and redistributing models. We'll talk about that later, but that took a while to figure out how to publish that. So here's another little arrow there. There's another sort of little publication I created, and it's called DDS 12. And basically, this publication is, over the years, every time a new survey was done, if it was adjacent, we typically got a merged grid out of that. And those are pretty handy, so you don't have to merge the data yourself. It's kind of nice. So currently I just have 3 merges in that, but I plan to add essentially all the ones I've received digitally from the contractors over the years. And the 3 that I have there actually kind of fall into technical development, so you'll be familiar with that. But I have like a toke area merge on sort of 40-mile area, and then the data around the local mine. So it's nice to just load these merge grids in. And then just the last thing, and I'm hoping, I look forward to adding more data into this regional geophysics data category. Soon we'll have at least a statewide mag grid out that's new. And gravity is on the wish list there too. But one I just put a link to because I thought it was a really nice product, speaking of the neighboring surveys, Canadian surveys. They published a nice, just regional magnetic merge. And I thought it was a nice product, so I put a link on it. Just to make people aware of it, because otherwise you wouldn't know it was out there maybe. So I broke all the rules in the presentation, put this long list of stuff up here. And that's kind of the point. There's 2 of us, and we have all these great things I really wish we could do. But some of these are going to win and some aren't, but this is my wish list. I really would like to improve data availability. That certainly speaks to this crowd's interest. And then going forward, some of our projects are requiring full interpretation, which is modeling inversion and working in a 3D environment. We're actually learning how to work in GoCAD. And then on the flip side of that, it's kind of nice to have some ground equipment just to do little follow-up surveys. It's hard to get people up into Alaska to do work. Everyone in this room knows this. So if we have something just sitting on the shelf that's easy to use, we're limited in staff, maybe it's quick, we can go out and do something. Improving the web page always, that goes back to the data. And I like people to come look us up for geophysics data, getting more regional stuff out there, look for more funding, and support other aspects that are within my group, either the engineering group or the energy group. And I'll stop there, you can read them later. Because really what it comes down to is we just got to focus one way or the other. We can't do it all. So we're going to have to balance being like a data resource, getting all our data online and properly archived. Data collections, 25 years or so of data, it's worth $20–30 million at least if we're going to recollect that. So it's really good to take care of that versus sort of fully using geophysics or promoting it within either our groups or even just people like you. That's kind of the point of this. Kind of sets the stage for this workshop as well as the promotion of how to use your geophysics to advance your projects. So excited to hear some of the talks. Okay, that's me.